In this video, we're going to do the free response labeled 2002 number 5. And so you can read this beginning part. It's just defining what an early bird is versus night owl is. And so they say they did a study to compare the dream recall for early birds and night owls, and 100 people for each of the two types were selected at random. So I'm going to go ahead and label my N for the early birds is 100, and my N for the night owls, which is, I guess I'll put NN, is also 100. And then they recorded the results below. And so then if we read part A, it says the researchers believe that night owls have better dream recall than early birds. Okay, so let's go ahead and write down what they're trying to test. They think that the night owls is going to have greater dream recall than the early birds. That's what this first sentence is saying. So then it says one parameter of interest to the researchers is the mean number of dream recalled per week, with mu E representing the mean for the early birds and mu N representing the mean for the night owls. The appropriate hypothesis would be this HO and HA. And so then they want you to come up with two other pairs of hypotheses that might be used to test the researchers' belief. And be sure to define your parameter. So they used the mean, and they would do a significance test with the sample mean to determine the hypothesis about the population mean. But then they're asking you, what else could you do? So we know we could also do proportion. And we have two different proportions we could use. We could set up a proportion for no dreams, or we could set up the proportion for 5 or more dreams. And then they actually, on the scoring guideline, they also, if you did median, even though we don't know how to do a significance test for median, you could still set up the hypothesis. But I would stick to proportion since that's the one we're most comfortable with. So for part A, my first hypothesis that I'm going to set up is I'm going to use the no dreams. So I'm going to define PE. Remember, you define just P, not P hat, because you should write a hypothesis with a population value. So PE is going to represent the proportion of early birds who, now don't put recalled, remember that's past tense, so that would be referring to the sample, just put recall, no dreams. And then PN is the same, but proportion of night owls who recall no dreams. And so then how would we set up this hypothesis? We know the null is that they equal, PE equals PN, or you could write that PE minus PN equals 0. Now the HA, remember they think that night owls recall more dreams. So which one would be greater? That PE recalls no dreams. So in this case, it'd be PE is greater than PN, which could also be PE minus PN is greater than 0. Okay, so just so you didn't think you were getting away with anything, this is not two sets of hypotheses. This is one set. Now we got to come up with another option. What other parameter could we use to compare these dream recalls? So the other proportion we could define is, instead of proportion who did no dreams, proportion who recalled 5 or more dreams. So we're going to set up, you can still use PE and PN, but we're going to define them differently. So proportion of early birds who recall 5 or more dreams. And then define your PN, proportion of night owls Who recall 5 or more dreams? So we set up our null the same, right? Our HO is always that they equal. So PE equals PN, that there's no difference in the recall for early birds and night owls, which is also PE minus PN equals 0. And then in this case, if we think about it, we think the night owls have greater recall, so we think this would be greater. So you could either do PN is greater than PE, or if we stick with putting PE first, then that would be, we think they recall less dreams than night owls. So if we were to move that over, PE minus PN is less than 0. So that would be your two different proportion setups for part A. Now part B says, let's pull it up, use the data provided to carry out a test of the hypotheses about the mean number of dreams recalled per week given in the statement of part A. Does the data support the researcher's belief? So now they're just wanting you to actually perform a significance test using these original hypotheses. So that's your just straightforward state plan do conclude. So I would go ahead and just rewrite, even though they already gave you the hypothesis, redo everything. So we know our state is what they gave us. Mu E minus mu N equals 0, which what's another way to write that? Mu E equals mu N. And then their HA was mu E minus mu N is less than 0, which means mu E is less than mu N. And then I would still go ahead and define our parameters. So mu E is the mean number of dreams recalled. Mean number of dreams, I'll say early birds recall. And mu N is mean number of dreams night owls recall. And then I'm going to go and write down our significance levels. So, I didn't notice how slanted that was. Our alpha equals 0.05. Okay, so for plan, what type of test are we going to do? Well, we know it's a mean problem, and we have two means, so that's two sample t-test. So then we check our conditions. So, did we take random samples? You can see here it says 100 people of each of the two types were selected at random. So we're going to put 2 independent random samples. So because they were random samples, we need to check the 10% rule. So what was our sample size for each one? It was 100, right? NE was 100, and N, oops, not capital N, lowercase n, N was 100. So we need to assume that both populations of early birds and night owls equals 1,000. I'm going to write that out. Assume both populations of early birds and night owls are at least 1,000. And then we need to check what if it's normal. So it doesn't say anything about normality. So we need to check central limit theorem. So because our sample size were both 100, we know they're greater than 30, so central limit theorem applies. So we can say because 100 is greater than or equal to 30, both samples are large enough for, I'll put CLT, so approximately normal. And there are your three conditions: random, 10% because it was a random sample, and then CLT for normality. So now we're ready to do due. So I'm going to have to flip it over. So we already said it's two sample t-tests, so we're going to go to our calculator and go to menu, stats test, two sample t-test is for, we don't have the data, so we want to change that to stats. And what is our X bar 1? So that's going to be our E. So our sample mean for early birds was 7.26. Our standard deviation was 6.94. And our sample size was 100. And now we're going to do night owls: 9.55, 5.88, and 100. And then our alternative is that E, which is our 1, is less than our N, which was 2. So change that to be 1 is less than 2. Always keep that no. And we're going to write down all this and draw our distribution. So our test statistic is T is negative 2.517. Our p-value equals 0.0063. Our degrees of freedom is 192.799. And when you're doing a two sample for a mean problem, I would definitely just write down the degrees of freedom from the calculator. It's going to be different than what you would have calculated. Because if you would have done it, it would have been 99, which would also get you credit. And then you don't really have to write down all this sample information because it was given, but if you want to write all that down, you can. And then we draw our distribution. This is a t-distribution with 0 in the middle. Put our negative 2.517, and then because our alternative was less than, we shade to the left. And that shaded area is this p-value, which is a lot smaller than what it looks like I shaded, but that's okay, as long as you labeled your test statistic right there. So now we're ready to conclude. So since p-value, which is 0.006, is less than alpha equaling 0.05, we reject HO, and that means we do have convincing evidence that, now we have convincing evidence for HA, but we're going to put it in context. So HA is that the mean number of dreams recalled for early birds is less than the mean number of dreams recalled for night owls. So you can just write exactly that or try to fit it to be shorter, but just make sure you don't take too many shortcuts and leave something out. The mean number of dreams recalled by early birds will be less than the mean number of dreams recalled by night owls. Notice I was trying to be careful because I said recalled and I didn't want that to sound like I was talking about a sample. That's why I included the will be, to make it sound like we're hypothesizing about something in the future, about a greater population. And that is everything you would need for that free response.